Hello, everyone. In episode 6, we're going to be talking about adding and subtracting fractions. In the last episode, we talked about how fractions are multiplied and divided. And in this episode, we're just going to finish up the operations by talking about addition and subtraction. Now, before I can talk to you about addition and subtraction, there is another little thing that I need to talk to you about. And I need to talk to you about what is sometimes called the least common multiple. When someone talks about a multiple, and someone uses that word multiple of a number, they're talking about something that you can get by multiplying that number by something else. So, for example, if someone wanted to list some of the multiples of 7, one multiple of 7 would be the number 7 itself, because 7 is obtainable by taking 7 and multiplying it by the number 1. The number 14 would also be a multiple of 7 because you can get 14 by taking 7 and multiplying it by 2. 21 would be a multiple of 7 because you can get 21 by multiplying 7 by 3 and so on and so forth. By multiplying 7 by different numbers, you can get different multiples of 7. Now, the times table is really nice when you are interested in multiples because the times table lays out a bunch of multiples of numbers. For example, in the row labeled 7, you can see a ton of multiples of 7. 7 times 1, 7 times 2, 7 times 3, and so on. You can get all the different multiples of 7 in this row here. Likewise, if I looked at the row labeled 9, the row labeled 9 would contain all the multiples of 9 up to a certain point. So 9, 18, 27, 36, 45, and so on. All of these numbers would be multiples of 9. Multiples of 9. When you're dealing with more than one number, when you're dealing with a collection of numbers, you will sometimes hear this word least common multiple. Least common multiple, the name almost explains itself. This is the smallest number, hence this word least, that works as a multiple, hence this word multiple, of all the numbers that are in your collection that you're working with. Hence this word common. Least, it's the smallest number. Multiple, that is a multiple of common, all the numbers in your collection. The smallest shared multiple, the least common multiple. So, for example, someone says, can we find the smallest number that works as a multiple for both 3 and 5? So I'm looking for a multiple of both 3 and 5, and I want it to be as small as possible. So for example, in the times table, if I look at all the multiples of 3, and I look in the times table at all the multiples of 5, what's the first number that shows up in both lists? I think the smallest multiple of both 3 and 5 in this case is 15. 15 is a multiple of 3, and 15 is also a multiple of 5, and it's the smallest multiple that works for both numbers. 30 also works for both numbers. 30 is also in both rows, but it's larger than 15 is. So I would use 15 as my least common multiple. 15 is a multiple of both 3 and 5, and it's the smallest such number, so 15 is the least common multiple. Someone says, what is the least common multiple of 3 and 6? I'm looking for a number which is a multiple of both 3 and 6. Now, if I look in the row labeled 3 for all the multiples of 3, and if I look in the row labeled 6 for all the multiples of 6, I see that the number 6 appears in both rows. The number 6 is a multiple of 3 because 3 times 2 is 6. The number 6 is a multiple of 6 because 6 times 1 is 6. So 6 is the smallest, the least common multiple of both numbers. What's the least common multiple of 4 and 6? Here, I'm looking for a number that is a multiple of both 4 and of 6. So I think the first number that I see that appears in both rows is the number 12. Multiples of 4 are 4, 8, 12. Multiples of 6 are 6 and 12. Aha, 12 is in both places, so 12 is a least common multiple. Now, it's also possible to have 3 numbers or 4 numbers and to be asked for a common multiple for all of them. And in a situation like that, I'm just looking for a number that shows up in all 3 of these rows. Here I'm looking in the 4's row and the 6's row and the 8 row. Can I find a number that shows up in all 3 of these rows? Now, I think the first number that shows up in all of the rows might be 24 here. So I think 24 will work here. 24 would be the least common multiple of these 3 numbers. The least common multiple is a nice and efficient way to rewrite 2 fractions or 3 fractions or 4 fractions so that they all have the same denominator. Back in episode number 4, Back in episode number 4, we rewrote fractions so that they had the same denominator so that we could compare which one was bigger. And the easiest way to do that back in this episode number 4 was just to steal a copy of the denominator of the second fraction and use that to multiply the first fraction and vice versa. That was definitely a way to make 2 fractions have the same denominator. However, sometimes there was a more efficient way to do it, right? Back in this example, when we were comparing 1 over 3 with 4 over 9, because 3 and 9 have a least common multiple of 9, all we had to do was change the first fraction so its denominator was 9, and we were able to answer the question pretty quickly that way. The least common multiple is going to help us to efficiently rewrite fractions so that they all have the same denominator. Step number one, if you have two or more fractions and you want to rewrite both fractions so they have the same denominator, the first thing that you can do is you can find the least common multiple of each of those fractions' denominators. I shall call it the LCM for short. Once you've found this number, rewrite each fraction so it has that LCM as the denominator. So for example, if someone says to me, rewrite 2/3 and 4/5 so that they have the same denominator, the first thing that I'm going to do is I'm going to ask myself, what's the least common multiple of the two denominators in these fractions, 3 and 5? Now, we did this one earlier. The smallest common multiple of 3 and 5 is 15. So I'm going to take 2/3 and I'm going to rewrite it so it has a denominator of 15. And I'm going to take 4/5 and I'm going to rewrite it so it has a denominator of 15. Now to turn 3 into 15, I'm going to need to multiply it by 5, which means I also need to multiply the numerator by 5, because when I'm rewriting a fraction, I'm not allowed to change the amount. And so I have to make sure that the numerator and denominator are multiplied by the same value. And 4/5, if I want to change that 5 in the denominator to a 15, I could hit it with a 3, and if I do that to both the denominator and the numerator, I get 12/5. So in some sense, I have reversed the simplification on these fractions. I have undone the simplification and I have made them more complicated, but I have made them more complicated in a way that they have the same denominator now, 10/15 and 12/15. Let's do it again with the fractions 15/4 and 3/2. Let's rewrite these fractions so that they have the same denominator. The first thing that I'm going to do is I'm going to find the least common multiple of the two denominators present in this problem. The least common multiple of 4 and 2. Now, if I list out the multiples of 2, 2, 4, I can see right away that 4 works as a multiple for both of these numbers, so the least common multiple is 4. This is great because this means that our first fraction, 15/4, already has the correct denominator. So I don't need to do anything here, and I can focus all of my attention on the other fraction and converting that so it has a denominator of 4 as well. So to get 2 up to 4, I can multiply by another copy of 2. That will turn the denominator into 4 and it will turn the numerator into 6. So to rewrite both of these fractions with the same denominator, one of them could just remain the same, 15/4, and the other one can be rewritten as 6/4. You can also do this if you're working with a collection of 3 or more fractions. In this case, I would just need to find the least common multiple that works for both 4 and 3 and 6, the denominators of each of these three fractions. Now, if I look at the times table to look at some of the multiples of 3 and 4 and 6, it looks like the smallest number that works as a multiple for all three of those is the number 12. So I'll take 1/4 and rewrite it so it has a denominator of 12. I'll take 2/3 and rewrite it so it has a denominator of 12. And I will take 5/6 and rewrite it so it has a denominator of 12. Now to turn 4 into 12, I can multiply by 3. And if I multiply both the numerator and the denominator by 3, it will become 3 out of 12. To turn this denominator 3 into 12, I can multiply it by 4. 3 times 4 becomes 12. 2 times 4 becomes 8. So this second fraction can be expressed as 8 over 12. And 5 over 6, to transform 6 into 12, I can multiply by 2. So 5 times 2 gives me 10 in the numerator above 12. And so I have 3 over 12, 8 over 12, and 10 over 12. That is the rewrite of these three fractions so that they all have the same denominator. In this case, the same denominator of 12. So this is how we can most efficiently rewrite fractions so that they all have the same denominator.